Canada, and today we have a special treat. We have with us Bob МакДоналд, who I have to say I've been following him without him knowing about this. I've been following him for many, many years. Bob МакДоналд is a Canadian author and a science journalist. He is the national science commentator for CBC Television, which is basically the national television channel here in Canada, and CBC News Network. And since 1992, this is 30 years now, Bob. That's amazing. For 30 years, he has been hosting a weekly radio science show known as Quirks and Quirks, which I follow both live but also podcast. So I'm always listening to his, these wonderful podcasts, and it draws approximately about 800,000 listeners each week. So the other thing about Bob is that he, besides being well known by people like Chris Hadfield that we had a number of months ago come and share with us what it's like to be on the International Space Station. Bob is also a very well-known author. He has written a number of books, and today he will be sharing one of them. So Bob, on behalf of all of Ukraine, thank you for being here today. It's a pleasure to have you.
Thank you so much, David, and thank you all of you from Ukraine for joining us today. It's a real pleasure. Yes, as David said, I'm a science journalist, so I write about science. I interview scientists from all over the world, and it's just been really, really exciting to do that. But my favorite subject, ever since I was a kid, has always been space. And my latest book, which is behind me here, is called An Earthling's Guide to Space. And it's based on questions that young people like you might ask, like, how do you get around in space? Why are planets round? Why do comets have tails? What's it like on Mars? Things like that. And so what I'm going to do for you today is I want to show you how all of you and me are already in space, how we're flying through space on our spaceship Earth. I'm going to make you a model, a working model of the Earth and the Moon that you can build yourself. And I'm also going to make a working model of a black hole in a bottle that you can also make yourself. But first, I want to tell you about, or show you a very short video of me on a very special airplane. And this is an airplane that they use to train astronauts for going into space. It's the only way that you can create zero gravity here on Earth, because when astronauts go into space, you notice that they're floating around weightless. It seems like gravity's gone away. What they're really doing, they're just falling all the time. They're falling around the Earth, so they're weightless. Well, the only way we can do that without going into space is to get into a big airplane, which is an airliner, but they've taken all the seats out. And they fly this airplane very high and over the ocean. And then they fly it like a roller coaster. They go up and down like this. They follow these very special curves called parabola. And a parabola is the natural curve that anything you throw in the air, you throw a baseball or any kind of object in the air, it follows a parabola in space. So when they go over the top of the hill in the airplane, everybody inside becomes weightless and you float around for 30 seconds. That's all you get, because after 30 seconds, the airplane is pointed down, so they have to pull it up. So then when they pull it up, you go back down to the floor and you feel twice your weight at the bottom. And then they do it again. So you go from twice your weight to no weight at all, floating around, then back to twice your weight. We did this 15 times, and you're going to see this in the video. But what's interesting is that at the beginning, the first two parabolas that they didn't go to zero. They just brought our weight down a little bit. And on the first one, they brought our weight down to 1/3 of what you weigh now here on Earth. So divide your weight by 3, and that's what they did. And the reason they did that is because that's what you would weigh on Mars. Mars is smaller than the Earth. So if you go to Mars, you'll only weigh 1/3 what you do here. So you'll walk differently. So you'll see what it's like to walk on Mars. On the second one, they brought our weight down to 1/6 of a G, which is the gravity of the Moon, because the Moon is even smaller than Mars. So let's see if I can make this video work for you here, and we'll see how it works. Here we go. hopefully you can see this. And let's see if it plays. Okay, can you hear it? Can you hear it?
We see the video, but we don't hear the audio.
Okay, hang on. Okay, my computer just crashed. Oh no. My computer just crashed.
You could stop sharing and then try it once again.
Everything just went black.
Uh-huh.
My whole screen just went black. Can you still see me?
Yeah, we see you and hear you. Yeah.
Okay, I can't see anything. My screen just went black. I don't know what happened. Oh, I'm so sorry about this.
I think you can go on, yeah, and then maybe it will work.
Nothing's working. My screen is totally black.
You can exit and again enter from Zoom session.
I have no control over my screen whatsoever. Everything just went black. Rats. I think what I might have to do is reboot my computer and rejoin the call.
Yeah, he did it. Okay.
Oh, and my my power is off. Can you see me, friends? My electricity went off. Yeah, no electricity, but hopefully I think I will have internet connection. It's fine. I think we will wait for Bob to come back, right?
Yeah. Yes, and unfortunately, yeah, his computer crashed. And, you know, those are the things that nowadays we just simply don't have any control of. And so right now, what he said, he's going to reboot and try to get back into our Zoom link and be able to share with you all the things he does. So again, if you missed this information, Bob is very well known here in Canada. I've been following him for something like 30 years, and I'm a school principal here in Canada, and my specialty in my school is science and technology. And so when he said that he was actually going to come and join us for this session, I was so excited. I thought, this is something that I just love. So he's written tons of books, and he has a following of 800,000 people every week that follow his program. So he has lots of people. And one of the people that follows him all the time is our very famous Canadian astronaut, Chris Hadfield. How many of you attended Chris Hadfield's session? Did any of you come to visit? Put your thumbs up if you were actually with Chris Hadfield. It looks like maybe not many of you. So it looks like I might have to invite him again. And Chris Hadfield, he's again very famous Canadian astronaut, but he piloted the space shuttle twice, not just once, twice. He actually brought it back to Earth. And on top of that, he was actually the International Space Station commander. And so he was basically responsible for this huge International Space Station for a period of 6 months. Can you imagine that? The responsibilities of basically taking care of this big spaceship that's just orbiting planet Earth. It's just going around and around and around. And in it, they're doing all sorts of science experiments. And so he was actually doing a lot of that work. So I see somebody's actually going like this. Yeah, rather than this, it'd be going like this, maybe like this. Absolutely. Now, I don't know if you know this, but if you go to the internet, you can actually find the path that the International Space Station takes every day. And I've actually followed it, and there have been times where it's actually flown above my house. So you can actually see this little, what it looks like a star, just very bright, just flying at very fast speed, flying over. And so if you are interested of ever seeing the International Space Station, just simply Google International Space Station and see whether or not it's going over your town, over your city. Because if it happens at night, the reflection of the sun on its solar panels, it's going to totally illuminate the International Space Station as it's going above you. And it's just, I have to say, it's amazing, because you sort of look and you go, wow, that is actually a spaceship there, and it's flying right over my house, and there are people in it, and they're doing some very fancy science experiments there. So now, Bob knows a lot more than I do, and he's been doing some fancy stuff, like he had actually said, you know, going into this jumbo 747. I think it's a 747, and they go high up and then they drop. And when they drop, they become almost weightless. And so he's had all sorts of possibilities, experiences, things that I have not had the chance to do. I'm actually going to be positive. I'm going to say, haven't had the experience to do them yet. Maybe I will have the possibility of doing them sometime in the future. So we're still waiting for Bob. Do you have any questions? So as I was saying, I'm actually the principal of a school here in Canada that teaches about engineering and technology. So, for example, I have a badge here that says Canadian Space Agency. And I'm going to go behind me, and I'm going to grab one of the overalls that we give our students to wear a lot of times. Just wait. One of these days, I think I'm going to wear this at school, but it's a very fancy suit that we use for our astronauts program. We actually have an astronauts program here in my school where we teach students how to become astronauts. Wouldn't that be cool? So they come here and they go into this back room. And in this back room, we have all sorts of things that they're learning about: computers and drones and spaceships. We actually build rockets here, and we program them, and we are able to know how far up they go. We have drones. So it's a very exciting place to be. So again, we are waiting for Bob. Any questions for me?
Yeah, we have two questions, but guys.
Hello. I have a question. Have you ever been to space by your own?
You know something, in my dreams I have. I wish I could say that I've actually been there for real, but in my dreams, you know, I am old enough. I think sometimes I feel like I'm a million years old. I am old enough to remember when man landed on the moon. And I was this very young boy, and I remember watching TV. It was a black and white TV, and my parents were there with me, and we were watching. And then we heard the news, man have landed on the moon. And I remember running out of the house, and I remember looking up to the sky, and I saw the moon, and I thought, wow, there are people right now walking there. And so I don't think I'm going to get the chance. But you know something? That's where Bob comes in, and he knows so much about space that he gets to share with us what it's like. So Bob, you're back.
I'm back. I'm back. I don't know what happened. My computer completely crashed on me, so I don't know if some hackers got into me or what happened. Holy cow. Sorry about that.
No
Sorry.
problem. So I'm going to turn this back to you.
Well, rather than mess with my computer, let me move on to what I wanted to show you. We are all in space right now, and here's our spaceship. I happen to have one with me. We are all on the beautiful planet Earth. And right now, you in Ukraine are, let's find you. Here's Africa, there's Saudi Arabia, there's the Mediterranean, the Black Sea. Ukraine is right there. So this is where you are. I am on the other side of the planet right now. I'm in Canada, so we have to go all the way over here, past China, Japan, go across the Pacific Ocean, over here to North America, and Canada is up here in the top part of North America. And I'm on the west coast of Canada right now on the Pacific Ocean, on a place called Vancouver Island, which is right there. So I'm here and you are over here. So we're almost half a planet apart right now. And in fact, we're at about the same latitude as we are where I am and where you are. But all of us are on this planet right now, and our planet moves, and it moves in a number of different directions at the same time. For example, every day you travel all the way around the world. Think about it, because the Earth turns and it takes you with it. And that's a long way to go all the way around the world in only one day. So you're actually moving quite quickly. And the Earth turns counterclockwise, so you're moving towards the east. So if you know which direction east is right now, wherever you are, or if you know where north is, turn your back to the north and the east will be on your left. So for me, it's that way. So you are traveling towards the east, you and me right now at our latitude. We're traveling at about 800 kilometers an hour. Now that's about the speed of a jet airliner. So you're moving at about 800 kilometers an hour just by sitting in your chairs at the moment. That's how fast Ukraine and Canada are moving around the center of the Earth. And that means that if the Earth were to suddenly stop turning right now, just suddenly stop, all of you would go flying and you would hit the east wall of your room at 800 kilometers an hour. It would be a big mess. And everything that's not tied down, all your furniture, all the cars in the streets, everything that's not tied down would suddenly take to the air and fly off to the east. The Black Sea would just wash up over the continent. The Mediterranean Sea would wash up over the Pacific Ocean would wash up over my continent. I'd be drowned right now if the Earth suddenly stopped turning. So it's a good thing that it turns every day. If you go south from where we are and you go down to the equator, you're moving even faster because the equator is farther away from the pole. If you think about, you go up here to the North Pole as the Earth turns, you don't move very much. But if you go down to the equator, you're following a much bigger circle. So at the equator, let's say down here in Africa, Tanzania is on the equator. Down there, you're moving at 1,600 kilometers an hour. 1,600 kilometers an hour. That's faster than the speed of sound. That's supersonic. That's the speed of a jet fighter. Just by lying on a beach in Africa, you're moving faster than the speed of sound as you travel around the world. At the same time, the Earth is moving through space because we go around the sun every year. It takes us a whole year to travel all the way around the sun. And to do that, we're moving even faster. So the Earth itself moving through space is moving at about 30 kilometers every second. 30 kilometers every second. So try to think of a place that's 30 kilometers away from where you are now, another town that's 30 kilometers away. and the way that the speed the Earth is moving, you could go to that town in 1 second. That's how fast the Earth is moving through space. That's about 100,000 kilometers an hour. You think a car on the highway does 100 kilometers an hour. It's 10 times faster than a car on the highway. That's how fast the Earth is moving through space as we go around the sun. And not only that, the sun moves through space and it carries us with it as the sun moves, and it's moving at 300 kilometers per second through space. So it's just amazing how quickly we're moving just sitting in your chair right now. So we're all astronauts. We're all astronauts. And if you think about, again, where you live, let's find out. I like to think who's on the other side of the world from where you are. So if you can find a globe like this, put your finger on where you are. So again, there's Ukraine. I'm going to put my finger on the other side of the Earth, hold it like this, then just turn it over and see who's under there. So under you right now is the South Pacific Ocean. That's what's under your feet, the South Pacific Ocean. There's South America. There's Australia. So you're somewhere between Australia and South America in the South Pacific. That's what's straight under your feet right now. And remember, if you go a little further than that, 12,000 kilometers straight down from where you're sitting right now, you will come to outer space. So there are as many stars under your feet as there are over your head. There are as many stars under your feet as there are over your head, because we live on a ball and this ball moves. Now, let me show you another way that you can demonstrate how the Earth moves and how the moon moves. I built myself a garbage can gravity well. So what this is just a bucket. You can use a garbage can. You can use anything that's round, a big flower pot. And I put a cloth over the top of it. It's actually my shirt. And I tied it with a string so that it's nice and smooth like a drum. Now, I hope you can see this. I'm going to tilt my camera down here, see if we can see the surface of this drum. Here, can you see that? Okay. I'm going to make it nice and level if I can. I'm going to take off my earphones too. Okay. Now let's suppose that this is space. If you take an object and you just put it out in space, it'll just sit there, won't go anywhere. That's Isaac Newton gave us 3 laws of motion. 1, an object at rest will stay at rest. It won't move. Law number 2, if you do move something in space, there's nothing around it, it'll go in a straight line like that. That's Newton's 2nd law. Objects in motion will go in straight lines and they'll keep moving unless you act them. And the 3rd law is for every action, there's a reaction. So if I hit the ball, it goes in the other direction. The action of my finger hits the ball and it goes action, reaction. Well, imagine that space is like this. If you put something heavy in space, something big, like a planet or a star, it causes the space to bend a little bit. It causes it to curve down. That's called a gravity well. If you have another object that's close to that planet, it will be attracted to it. It will fall down. And it doesn't matter where you are, any direction, it'll fall down, because gravity always pulls towards the middle. And that's why planets are round, because they're trying to be as small as possible, so they form into a sphere. If you jump up, you will fall back down again, right? So you go, what goes up comes down, right? Oops, sorry. Okay, I'm trying to keep this level here on my lap. Now, if you want to travel in space, you have to get out of that gravity or go faster so that you don't fall down. So what you do to go into space is you go sideways and you can orbit around it. And that's what we do with our rockets. We go up and we go sideways at just the right speed so that we will follow the curve of space and orbit around. And to do that, you need to go 30,000 kilometers an hour. and you can ride the walls of the gravity well. If you go too fast, you will escape and fall off the edge. But that's what you do if you want to go to the moon. If you want to go to Mars, you got to crawl out of this gravity well. But this is something that you can make yourself. Try, maybe put a piece of plastic over here, or try different fabrics and see if you can make something orbit around the Earth. This is what satellites do going around the Earth. This is what the moon does going around the Earth, and what the Earth does going around the sun. So space is curved. That's how Einstein saw space, and that's how gravity works this way. The bigger this object is, the deeper the gravity well becomes, which means if you want to get out of it, you got to go even faster. And if it gets really big, really deep, really super, super deep, the speed that you need to get out gets so fast, you have to go at the speed of light to get out. And when that happens, you don't get out, because nothing goes faster than light. So if this gravity well gets so deep that you can't get out of it, that's called a black hole. Black holes are just super, super deep gravity wells created by giant stars that collapsed in on themselves so that nothing can get out. That is a black hole. Now here's a way that you can make a black hole in a bottle, a working model of a black hole. Oh, do we have a question? Is somebody raising their hands? No, we're okay? All right. Here's a way that you can make a black hole in a bottle. Now, all you need are two plastic bottles like this. They don't have to be these big ones. They can be smaller ones. This will work. And I've got two of them. One of them filled with water. The other one, I've done something with their caps. You have these screw-on caps. What I've done is I've drilled a hole through the caps, and the hole is about the size of my little finger, like that. And then I've taped the two caps together so that the threads face outwards. So I can put one cap on here like this, nice and tight. And then I can put it on top of the other bottle this way so that they hook together and make them nice and tight like this. Now, this is the tricky part. What you have to do is carefully turn them over and swirl the top one around and watch what happens. You see that? Isn't that beautiful? Now, you've probably seen that shape going down a drain. You pull the plug in a sink or a bathtub or a toilet bowl. That shape is called a vortex, where the water is swirling around and around, going through a hole and coming out into another space. That's also the shape of a black hole. When you get close to a black hole, you get caught in its gravity. You start to swirl around, going faster and faster and faster. And at the same time, you're getting squeezed tighter and tighter and tighter. And you go around so fast and you get squeezed so much that you heat up and you become white hot. And then you get stretched out. It's called spaghettification. You get stretched out into a long string of spaghetti that then swirls around and falls into the black hole. Not a very nice day if you get close to a black hole. And once you do go through the black hole, where do you end up? Well, we don't know. We don't know, because a trip into a black hole, which would be right here, is a one-way trip. You go down, you can't come back up. Nothing gets out of a black hole. So even if you survived and got through to the other side, we wouldn't know about that. You couldn't call up to us and say, hey, it's really nice here on the other side. Why don't you come on over, have a look? You can't do that because your voice wouldn't get out. Even if you shone a flashlight or a laser beam up, the light wouldn't get out. It would turn back again because the gravity is so strong here in the black hole. So there's a black hole that you can make in a bottle. Think about it. And if you ever get close to a black hole, don't fall in because you won't come back. How cool is that? Woohoo! Just let that run down. Pretty neat, huh? That, by the way, is called an accretion disk. stuff falling into a black hole. Now, what I'd like to do, I'm going to try, if you'll just bear with me here for 1 second. Does anybody have any questions so far? I saw a couple of hands up.
Yeah, we have some questions. Yeah, Diana, please. Go ahead.
Yeah, I have a question. Well, you said the speed of light is really high, so can the light get out of the black hole?
No, no. The speed of light is 300,000 kilometers per second. So you could go to the moon and back in a second and a half. The speed of light, that's what defines the black hole, is when the speed to get out becomes the speed of light. That's called the event horizon. You fall in, you go, as you approach the black hole, you go faster and faster and faster. And when you get to the hole itself, you are traveling at the speed of light. So that's when you can't go back. Okay.
Thank you.
Okay. Good question.
Thank you, Diana. Ілля Куплієнко.
I do have a question. Why in the cosmos we don't have the air?
Why? Ila asks, why is there no air in the space?
Why is there no air in space? That's a good question. There are gases in space. There are gigantic clouds of gas that float around between the stars, but it's very, very thin. And in fact, we came from a cloud in space that condensed in on itself. And in that cloud was dirt and dust and rocks, and they all congealed together. Most of it came the sun, and what was left became the planets. But the main reason that we have air here on Earth is, again, because of gravity. So the gravity of the Earth keeps the air on the surface, and it doesn't want to get out. It's always stuck, just like you are, to the surface of the Earth. Right now, you're being held in your chair. The gravity of the Earth keeps the air stuck to the planet. And some planets have more air than others. Venus has more air than we do, so it's a little thicker. Mars doesn't have as much air as we do. Its air is really thin, but it's the gravity of the Earth that keeps it there. And our air, believe it or not, has come from inside the Earth. It comes out of volcanoes. When volcanoes erupt, they feed our atmosphere, and that's where our air came from. But it's the gravity of the Earth that holds it there. Otherwise, space is just empty. It's so big that there's nothing out there. There's just nothing out there. Does that make sense?
Oh, wow.
Yeah. Okay.
Yeah. Oh, Ila said, thank you. Guys, if you have more questions, please raise your hands. And if you are able, turn on your cameras, please, okay? I see Paulina. Turn on your mic.
Yeah.
Good. Go ahead.
Yeah, hello.
Hello.
I have got one question. It's true what NASA found a discard body in a stone that looks like a worm. It's true in Mars.
Okay, there's something on Mars that I'm not sure I understood the question about Mars. We saw a worm, did you say?
The NASA found a discarded body in a stone that looks like a worm in Mars. It's true?
Yes.
Or no?
There are lots of rocks on Mars that look like worms, that look like statues, that look like animals, that look like pyramids, but they're just rocks. You can find rocks on Earth that look like that too, but that doesn't mean that there's life there. We have not yet found life on Mars. There may be life, or there may have been life on Mars in the past, because we know that Mars used to have lakes and rivers and more air like the Earth does. But that was about 3 billion years ago. 3 billion years ago, there were two blue planets, Earth and Mars. But that Mars went cold it didn't have enough gravity to hold on to its air, so the air leaked into space. So Mars went very, very cold. So today on Mars during the daytime, it's about -20, -30 degrees. At night, it's about -90. See? So if there was life there, it's either frozen now or it's underground. So we don't know if there was life in the past, but they're looking for it. The NASA rovers that are there right now are taking rock samples, and they're going to bring them back to Earth. And we're going to look and see if we see any microscopic life. But so far, there's no proof that Mars has life or did have life. I hope they do find it, but we haven't found it yet.
Okay, thank you.
Okay.
Thank you, Polina. Oh, wow. We have many questions. Okay, Maxim, turn on your mic, please.
I have a question. Why we are die in a space?
Why will you die in space? Because
How?
you have. How would you die in space? Oh, okay. Let me show you how you will die in space. If I was to go into space right now and I'm not wearing a space suit, I just open the door and go outside. Here's what happens. I breathe out, but I can't breathe in because there's no air. And then there's no pressure around my body. So my blood would boil and it would burst out of my eyeballs and it would form red snow in front of my face. It would come out my ears and my mouth. And I would be frozen, and then I would be cooked by solar and cosmic radiation. I would live for about 15 seconds. That's how long I would have to live in space. So not a nice day. Not a good way to go.
Thank you.
You're welcome. Don't try it.
Thank you, Max, for a wonderful question. Thank you. And thank you, Bob, for making it obvious. Okay, have Ariana, next one. Turn on your mic.
Good evening, I'm Ariana. This is interesting information in my opinion. You need to know this. Have you ever flown in a rocket or seen the sun up close with your own eyes?
Have I flown in a rocket myself?
Yes.
I have seen a rocket launch. I have not been in space yet. I hope to someday. But I have been on a zero-G airplane. I was going to show you a film of that earlier, but my computer crashed, so I'm afraid to turn it on. So I have experienced weightlessness, where you float around like an astronaut, and it's a lot of fun. It's really fun, but you have to move very slowly when you're weightless, because if you touch anything, you start moving and you can't stop until you hit the wall. So you have to plan where you want to go and just take your time, and everything's with your fingertips. You all just float around. So I have experienced that, but I haven't been in space yet. Maybe someday.
It's pretty cool. One more off-topic question. Can you play the guitar?
Oh, you see this? Yes, I can play a little bit. Yes, I'm not very good, but I don't care. I play for fun.
Okay, thank you. Thank you.
Thank you, Ariana. Okay, I see Taras. Taras, turn on your mic, please.
I wanted to ask, can you try and show us that video at the end of the lesson? So if it crashes, so it won't really matter because it's already the end of the lesson. And also, is it true that you get inflated like a balloon in in space?
Will you get inflated like a balloon in space?
Well,
Well,
not like a
no.
balloon, something like everything's like stretched out as much as possible.
If you go to a black hole, yes.
I
When you go
mean,
to
stretched out like
just
I
gets
mean,
bigger.
if you don't breathe out, like your lungs will pop like a balloon or something.
Yes, they will. Yes, they will. Your lungs would burst, and all the fluids in your body would boil, because we need air pressure around us to keep our blood liquid. Any liquid, when you put it out into space, will boil into a gas. So
Okay,
your blood
and
will do that
also-
in your body, which isn't good.
Can we watch the video right at the end of the lesson?
Oh, my wait list? We can try.
Right at the end, not right now, because if it crashes,
I'll-
we'll have to wait a long time.
Okay. All right, I'll try at the end. We'll see if we can make it work.
Okay.
How are we doing for time? We're okay.
Mhm.
Other questions?
I think, more we have, I see Stacy, but Stacy, please turn on your camera if you can. If you would like to ask the question. I turn on your mic. Okay. Can you speak?
Hello.
Yeah.
Hi.
Hello.
Do you know what is the nearest black hole to our solar system, and what is of gravity inside a black hole?
That's a good question. I believe I don't know the exact distance to the closest black hole to us. It's a few hundred light years, and it's very small. But there is a very large black hole at the center of our Milky Way galaxy, which is 30,000 light years from here. So that's a long, long way away. We don't have to worry about that one. But the black hole in the middle of our galaxy holds our whole galaxy together. Our galaxy is a beautiful spiral that we live in. But there's no black hole super close to the Earth that will swallow us, so we don't have to worry about getting eaten by a black hole.
Okay.
Okay, Stacy, is it all? Yeah, you
Yeah,
want to?
that's all.
Yeah, thank you. Thank you for the question. Good. And now I see Boris. Yeah, Boris, if you would like to ask something. So yeah, I unmute you. Turn on your mic.
Hello, I have one question. What are the good for a life, a moon or the Mars?
Should we go to the moon or Mars? Is that your question?
I think the question was like, is it better to live on the Mars or on the moon? Right, Boris? Am I correct?
That's a good question. They want to go to the moon first to practice, to see if the technology of living on another world works. The rockets to get there, the habitats to live in, the spacesuits, and the robots to drive around. They want to test it on the moon because if something goes wrong, you can get home in 2 days. You're very close to the Earth, or we can send help if something goes wrong on the moon. Mars is much farther away. It takes 7 months just to get to Mars. That's how long the journey is. So if something goes wrong, you have to wait 7 months for an ambulance to come and get you and help you out. So people on Mars will be completely on their own when they're there, have to fix their own problems. Now, Mars has more to offer than the moon does. The moon is just basically a rock. It doesn't have any air. There might be some ice at the South Pole that they're going to go look for, but Mars does have air. It has an atmosphere. You can't breathe it. It's all carbon dioxide, but it does have air, which means it has weather. So it has wind, it has clouds, It has ice. There's good skiing there. At the North Pole on Mars, there's ski hills. If you could get there, and you would only weigh 1/3 what you do here, so you'd really spend a lot of time in the air. The tallest mountain that we know of in our solar system is on Mars. It's twice as high as Mount Everest, more than twice as high as Mount Everest. It's a huge volcano. There are canyons there that have walls that are many kilometers high. So there'd be good rock climbing on Mars. So there's wonderful scenery, things to see on Mars, but it's so far away that whoever goes there will have to be able to take care of themselves. So that's why they're going to the moon first, then we'll go to Mars. So we'll see how that works out.
Great, thank you. Chris? Thank you.
Thank you for the answer.
Yeah.
You're welcome.
Okay, and we have Diana. Turn on your mic.
Yeah, I have one more question. I saw a fact on the internet that is it true that sun will burn out in a couple of millions years?
Yes, it will, but it will be several billion years, not millions, billions of years. And yes, it will. And when it does, before it dies, it's going to get bigger. It's going to go through a phase called a red giant, and it's going to swell up so much that it will swallow Mercury, Venus, and Earth. So we will be inside the sun. That'll be the end of the Earth. When it reaches us, it'll completely fill our sky. Our atmosphere will be burned away. The oceans will boil and go off into space. The Earth will have a tail behind it for a while as our water and our air burns off into space behind us. And then we'll just become a burned out cinder inside the sun as it swells up into a red giant. But that won't happen for about 4 billion years. So you've still got time.
Okay, thank you.
Thank you, Diana, for your question. Yeah, Nastya, and then Polina. Okay. Nastya, turn on your mic.
Hello, I heard you wrote a book. Can you tell about this book, please?
Yes, I can. And I have it. It's called An Earthling's Guide to Outer Space, and it's right here. Let me see if I can get that for you. This is my book. It also comes in audio. You can get it online. It's called An Earthling's Guide to Outer Space. And it's based on questions. So every chapter is a question that you might ask. So for example, the questions are, is there life in space? What is dark matter? Why do some planets have rings? Why are planets round? How do I become an astronaut? Do other planets have weather? So each chapter has the answer to those questions, but there are also things you can do, like what I just did here, like how to build a black hole, how to make a gravity well, how to do things at home that will help you understand space. So it's called An Earthling's Guide to Outer Space. Everything you ever wanted to know about black holes, dwarf planets, aliens, and more.
Wow.
That's what it's called. So you should be able to get that.
Thank you.
Look for it online.
Thank you. Polina?
Yeah, I have got one question. Do you know why it is in planet Earth that there are 100% living beings and not, for example, the same Mars or another planet?
That's a very good question. That's a very good question. We live in a very special place. Our planet is just the right distance from the sun. We're not too close. If we were, we'd be too hot, like Mercury or Venus. If we were too far away, we'd be too cold, like Mars or Jupiter or Saturn. So we're in the habitable zone of our star, just the right distance so that we're not too hot and not too cold. We also have a lot of water on our planet that's in the liquid form. Mars has water, but it's all frozen. It's ice. There are ice. Pluto is made almost entirely of ice, but it's frozen. Maybe there's liquid water underneath in an ocean, but we have liquid water on the surface. We have oxygen in our atmosphere, and we're just the right distance from our star. Now, at the moment, we know of at least 5,000 other planets going around other stars. And the ones that we're interested in are those that are in that habitable zone, that are just the right distance from their stars, that they could have life on their surfaces. And those are the planets that we're looking at and hoping to find another planet Earth. We haven't found one yet, but they're out there. And so there's, maybe one of you will be the ones to find another Earth out there. But it's got to be at just the right distance from its star.
Okay, thank you very much.
You're welcome.
Thank you, Ruslana. I see your hand is raised.
When the sun will burn, people will live or no? Before the sun will burn, people will live or no?
Well, before the sun goes, will people live until that time? Is that what you're saying? Well, life will go on. Whether people live that long, I don't know. I don't know. We are very new to this planet. The Earth has been around for 4.5 billion years. Humans have only been around for maybe 6 million years. So we're very new. We just arrived. There's been life on our planet for a long time without humans. And whether or not we'll keep going, I don't know. There used to be dinosaurs. Dinosaurs lived here for 150 million years, and then they died off when an asteroid hit the Earth and changed the environment. So I believe that life on Earth will continue, yes. Whether human life will continue, how long we continue, I think a lot of that has to do with us and how we take care of each other and how we take care of our planet. I hope so. I hope so, but I don't know. But life will, yes.
Thank you.
Yes.
Thank you, Ruslana. So we have I think 5 minutes more, and I have. May I
Do you want to
ask
try the video? See if I can make the video work.
Yeah, let's try.
Hang on one second. Yeah, okay, we'll try. All right, just give me 1 minute. All right. Now, can I share my screen?
Yeah, you are a co-host, so you are able to share your screen. Do you see this button?
Okay. Okay, here we go. Let's see if we can see this. Can you see that?
Yeah.
Let's see if it plays. Can you hear it? Can you hear it?
We don't hear the sound. There is no sound. We just see the video.
Okay. Are you hearing the audio?
We don't.
No?
No.
Okay,
No.
Here I am. Here's the gravity of Mars. Here's the gravity of Mars. So I'm jumping around, only weigh 1/3 what I do here on Earth. So it's really great. So walk like a Martian. Walk like a Martian. Okay, so we get down on our backs on the floor, and the pilots are now pulling up on the airplane. They're facing the clouds, and then they're going to start to go over this time. And we're going to go a little steeper this time, so I feel even lighter. Now, this is the gravity of the moon, and I feel really light. Watch. Woo! You fall slowly on the moon. You come down slowly, which surprised me. And I'm going to try to do a backflip here. Watch. Yeah, I'm going to flip right over. Woo! Easy, piece of cake. And here we go for zero gravity. So this is what astronauts in space feel. And it's really cool. You just fly all over the room. You can go in any direction you like. There's no up, there's no down. And all of us are crazy. We're just everywhere. Okay, after 30 seconds, we're back on the floor. So now we're going through the bottom and we're starting to feel twice our weight, getting heavier and heavier. So I'm weighing twice as much now as I do sitting in a chair. And here we go one more time over the top. Look at me, I'm in space, just like an astronaut. Now, what I wanted to do here was throw a ball to show you how it works, but I couldn't get to it because I'm stuck in the middle of the room. And then they spun me around. Hi there. Hi there. Pretty cool. Ah! I always ended up in my head. Didn't matter what I did. Anyway, so that was pretty cool, being able to do that and experience what astronauts feel in space. The other interesting thing I found is that when you go head first, like Superman or Supergirl, it feels like you're going up. If you go feet first, it feels like you're falling down, even though there's no difference. So you can, it's better to go head first. That's what it felt like, but it's very, very cool. So maybe one day some of you will get up in space and get to experience it for real.
Yeah. Okay, so I think we came to the end. So guys, now I will unmute all of you so you can say thank you. But first of all, I would like to say thank you, Bob. Thank you for your participation and your support. It really matters to us, and I see that kids are so excited. I was also excited. I'm not into the space, but you know, I was like, oh, wow.
Well, the next time you see a starry night, when you're outside at night and you look up at the stars, think of them as out. They're not up, they're out. And think about how far that goes, and that you are living on a ball. Where is it? Just remember, you're traveling through the space all the time on your spaceship Earth. Don't forget that.
we all are astronauts. It's so interesting, you know.
That's right. That's right. So enjoy your time in space.
Okay, guys, now you can unmute yourselves and say thank you.
Thank you.
This was
very
interesting.
Very interesting. Thank you.
Thank you. Thank you so much. Thank you so much this morning. Nice meeting you all. Bye-bye.
Goodbye.
Bye-bye.
Bye-bye. Thank you.